Hello, Miss Fallen and everyone. Uh, Welcome. My name is Stephen Cornelius. I'm from 12B, and today I'm gonna present to you the dynamic electricity concepts, principles, and applications, which is in Bab 2 of Fisika, the physics book. So now, first, what is dynamic electricity? So basically, dynamic electricity is the movement of electric charges, primarily electrons, through conductive materials. This flow of charge is crucial for the operation of various technologies and systems that we rely on daily, from basically from our household devices to large scale power grids. So like from our phones like this to PLN and stuff like that. So here is the basic idea, basic concept. Okay, next. Sorry. Alright, so here are some fundamental concepts of electricity in dynamic electricity. So first, we need to understand these in order to get the whole idea on understanding dynamic electricity. So first, the concepts are electric charge. This is important. So basically, electric charge is a fundamental property of matter, manifested in positive and negative forms. It is responsible for electric forces and interactions influencing how particles behave in electric and magnetic fields. And second, you might have heard of this before. It's called voltage or voltase in Indonesian. So basically, voltage or electric potential difference is essential for the movement of electric charge. It represents the energy per unit charge needed to move charges through a circuit, indicating how much work can be done by the electric charge. And now we move on to current. So basically, current is defined as the rate of flow of electric charge measured as amperes, or A, as we call it here. It can be thought of as the amount of electric charge that passes through a conductor in a given amount of time, which is connected to voltage, the previous concepts that we have highlighted earlier. So yeah, it's basically voltage or the amount of electric charge that passes through a conductor in a given amount of time. Usually, this can range from small to big. It's crucial for understanding how these devices operate. That is relevant to our subject, dynamic electricity. And then lastly, we have resistance. This one is gonna show up quite a lot. So basically, resistance is the property of a material that impedes the flow of electric current, measured in ohms. So the symbol of ohm can be shown here because the website is glitching, but it's basically a huge O sign. So basically, it determines how much current will flow for a given voltage, and it influences the efficiency of electrical systems and devices. And yeah, now we move on to the next one. So here are the three key principles of dynamic electricity, which is first, conservation of charge. The electric charge is a fundamental property of matter, ensuring that the total charge in a closed system remains constant. This principle is crucial for understanding electrical interactions and preserving energy in circuits. Then we have electric field. So basically, the electric field is a vector quantity that represents the force exerted by an electric charge on other charges in its vicinity around it. It basically describes mathematically as E equals F per Q, where E is the electric field, F is the force, and Q is the charge. Then lastly, we have circuit theory. Circuit theory basically involves understanding how current flows through various components in an electrical circuit. This theory is foundational for designing and analyzing circuits, ensuring that they operate effectively according to Ohm's law and Kirchhoff's laws, which we will get into later. So alright, but first we need to understand there's basically two types of electric currents that we have to thoroughly understand to get all this stuff. So basically there is one alternating current and two direct current. So what are they? Alternating current is characterized by the periodic reversal of its direction. The type of current is primarily used in residential and commercial power buildings, allowing for efficient transmission over long distances due to its ability to be easily transformed to different voltages as you wish. And then there's direct current. So direct current, in contrast, maintains a constant direction of flow. It is primarily found in batteries and electronic devices such as your basically any electronic devices that you can find, be it a phone, a charger, a TV, which one that has a cable. It basically has a direct current. So yeah, so direct currents, they're constant, and also consistent voltages is required for the accurate representation and operation for components like microprocessors and LEDs, basically the internals of a phone and the hardware inside of it. Whereas alternating current is basically used in huge power grids across the country, which is ideal because it can be it can be transformed into however much you wish. Alright, so we get to Ohm's law, which I've already explained previously that we're gonna explain, so now we're gonna explain it. So basically, what is Ohm's law? Ohm's law is a fundamental principle in electrical engineering and physics, establishing the relationship between voltage, current, and resistance in an electrical circuit. It emphasizes that increasing the voltage will result in a proportional increase in current, provided the resistance remains constant. Alright, that's basically it. Yeah. So now we're going into the first and second Kirchhoff's law, which is gonna get a little bit complicated from here. So basically, the first Kirchhoff's current law states that any junction in an electrical circuit, the sum of currents entering the junction must equal the sum of currents leaving the junction. This principle is essential for analyzing complex circuits and ensuring the conservation of electric charge. So basically, the amount of electrical charge you put into a wire has to be outputted as the same. So basically, like putting water through a pipe, it doesn't just go anywhere. It has to, all of that water needs to be released, and it must stay the same. Alright, so we're going into second Kirchhoff's voltage law, which states that in any closed loop in a circuit, the sum of the electrical potential differences or voltage must equal zero. This law is used to calculate the voltages in complex circuits and ensures that energy is conserved within an electrical system. And here is the formula or rumus in Indonesian. There's also one for Kirchhoff's current law in the first one. All right, so it basically all culminates to this, where all of these concepts are put into practical applications. So like, so that is in a nutshell what series and parallel circuits is. So basically, there are two types of how you organize electricity through the concepts that we have learned previously. So first, series circuits or rangkaian seri in Indonesian. In a series circuit, all components are connected to a single path. So the same current flows through each component. If one component fails, then it all stops working. That's basically it. Series circuits are basically often used in applications where the operation of devices is dependent on one another, and it is quite a simple system that is easy to learn and fix and reverse engineer. It's basically used very frequently in the lights in your house. Well, not all of it is just one room where just how do you call it? Turning on one switch will basically turn on all the lights. But then there's parallel circuits, which as you guessed it, is the complete opposite of series circuits, where parallel circuits, all components are connected across common points, allowing multiple paths for current to flow. So basically, if one fails, the other doesn't fail. Whereas in series circuits, if one fails, then all the other lights fail. That's basically it in a nutshell. But the trade-off comes with parallel circuits, being more complicated to maintain. And parallel circuits are commonly used in household wiring, ensuring that if one appliance is unplugged, others remain powered. Like how do you call it? The chargers in the wall. So here are some of the examples of dynamic electricity that we can practically see in our daily life, such as household appliances usage, LED lighting systems, smartphone and computers, electric vehicles innovation, and industrial machinery reliance. Alright, so that's all of the concepts and everything you need to know about dynamic electricity. I hope it is very useful for any viewer that is looking at this. And thank you, and sorry for any mistakes that I make, and thank you for listening to my presentation, Miss Valen and everyone.